Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. In this tutorial, we will be creating the line graph view. The purpose of the line graph view is to create horizontal and vertical lines and to add data points to the line graph. So within your projects from last week, create a new file, Swift file, and name it line graph. So you just click on the control key and then left click on the mouse, click on new file, Swift file, SwiftUI view file. Click on next and then enter the name line graph. And then after line 10 enter the following: let data points product. So the purpose of the data points products array is to have an array of data points that includes the JSON array from the file, which is order count, that has the key value. Let graph width CG float. Let graph height CG float. And then we need to create our state variables. At state private var path completion CG float is equal to 0.0. And the purpose of the at state path completion variable is to control the drawing of the line from 0 to 100%. It's used within animation, so it goes from 0 to 100% in a slow way. At state private var selected data point product with nil. And the purpose of that variable selected data point is that it enables the user to select a data point on the line graph, and then when they select that data point, the data point on the line graph will display the actual value of that data point. For example, I think the previous one is still on the screen. I think if we click on that one, for example, there's a data point and it shows 5,000. The next thing we need to do is to create a geometry reader. That's on line 20. So just type in geometry reader geo in. Let width equals geo dot size dot width. Let height equals geo dot size dot height. Let x scale CG float equals width divided by CG float data points dot count minus 1. And the purpose of that line 25, is that it calculates the scaling factor for the x-axis by dividing the width by the number of data points. Let y scale CG float equals height divided by CG float data points dot map $0 dot order count dot max question mark 1. And what that line does is similar to the previous one, but this line, it calculates the scaling factor for the y-axis by dividing the height by the maximum order count. Or 1 if there's no data point. That's the optional. And what else? I missed out something. It's a bracket. Order count. Equals height divided by CG float. Oh, that should be CG float. Next thing we need to do is to create a Z stack. And now we need to loop through the range of values to create the horizontal grid lines. So what we need to do is to create a for each loop. For each 0 dot dot less than 6 ID self I in let y equals height minus CG float open bracket I close bracket times by height divided by 5.0. And what that line does, it calculates the vertical position for y for the current horizontal grid line. Next thing we need to do is to create a path for the horizontal grid line. So just type in path. This is another closure. Path dot move to CG point X 0 Y Y. So what that does is it moves to the starting point of the line. Oh yeah, we need in on line 35, so that should be path in. Path dot add line CG point open bracket X colon width Y Y. And the purpose of that line is to add a line segment to the ending point of the line. The preview, we can delete it because we're not using it. And then after line 38, just add dot stroke open bracket color dot white dot opacity 0.5 line width 0.5. And what that line does, it sets the horizontal line color to white with opacity of 0.5. And then the next thing we need to do is to display the label text for the current horizontal grid line. So to do that, we're going to use text. So type in text, open bracket, comma, I times, open bracket, data point, dot map $0 point order count dot max question mark 1 and then we need to divide by 5. Dot font, dot caption, dot foreground color, white, dot position, CG point -20, and then Y. So what that does, it sets the label text color to white, and then it positions the label to the left of the grid line. Now, the next thing we need to do is to loop through the chart to create the grid lines, to create vertical grid lines. So to do that, we need to create another for each loop, similar to what we've done previously. So for each zero dot dot is less than data points dot count ID self I in let x equals CG float open bracket I times by X scale. And then we need to create a vertical path for the grid line. So that's path in path.move to CG point X Y 0. And the purpose of that line is to move to the starting point of the line at the bottom, and then we have to create another path dot add line to CG point X Y height. And the purpose of that line is to add a line segment to the ending point of the line at the top. Dot stroke color white, opacity 0.5, line width 0.5, and the purpose of that is to set the vertical line color to white with opacity of 0.5. And then we have to create another path. And this path will be for the data points. So after line 55, enter the following path in for index product in data points enumerated let x equals CG float open bracket index times by x scale So the purpose of that line is to calculate the horizontal position of x for the current data point. And then we're to do something similar for y as well. Let y equals height minus CG float product order count times by y scale. And that line calculates the vertical position of y for the current data point. If index is equal to 0, path.move to CG point x and y. So what that does, it moves to the starting point for the line if it's the first data point. If it's the first data point, that means the index is at 0. But if it's not the first data point, then it will do this within the else statement. Path.addLine to CG point x y and then close bracket. And then now the next thing we need to do is we have to trim the path from the start of position 0.0 to the current value for the path completion to create the animation effect. So when the line graph line is moving from 0.0 to the destination, so to do that we need to do it on line after line 69. So what we need to do is just type in dot trim from 0.0 to path completion. Dot stroke dot black dot line width 2 dot on a pair with animation dot ease in out duration 2.0. Path completion equals 1.0. So what that line does, it animates the path completion property from 0.0 to 1.0 with an ease in, ease out effect over 2 seconds. And then the next thing we need to do is, after line 79, to type the following: dot drawing group. And the purpose of dot drawing group, it just improves the rendering performance when doing dynamic drawings. For each data points, indices ID, self index in, let product equals data points index. So what that line does, it just gets the current product from the data points array by using the index on this line. Next thing we need to do is to calculate the horizontal position x for the current data point. So just type in let x equals CG float open bracket index times x scale, and let y equals height minus CG float and that should be CG float open bracket product dot order count times by y scale. And what that does, it calculates the vertical position of y for the current data point based on the order count and scaling factor. So the next thing we need to do is to create buttons, like add buttons to the data point, so that when the user clicks on the data points, it will be like a button event, so that the actual data point value is displayed by clicking on it. So what we need to do is to create a button, so that's button action selected data point equals product and then we need a circle fill dot white dot frame width selected data point equals product question mark 50 colon 8. Height selected data point equals product question mark 50 colon 8. So what that line does, those two lines, it creates the height and the width of the clickable data points for the button. And then the next thing we need to do is to create an overlay. So just type in dot overlay. Text open bracket selected data point equals product question mark product dot order count colon comma. And then we need to add a little font style dot font dot caption dot foreground color dot black and then after line 105 just enter dot button style plain button style dot position CG point X and Y. Let's compile it just to see if it compiles or not. Yeah, it compiles. Next week we will add the line graph view that includes the actual interface so that the user can interact with the application, such as clicking on the data points and displaying the full graph. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.